This presentation is on the Backrack H10 Pro leak detector. We will go over the settings, the control setup, and the operation of the unit. The Backrack H10 Pro detects all CFCs, HFCs, and HCFC refrigerants. It has both a manual and automatic mode of operation. The auto zero balance control and the automatic mode sensitivity levels are automatically adjusted. It has a patented heated diode sensor, a unique sensor calibration system, and it pinpoints both small and large leaks in automotive, refrigeration, and residential systems. This is a front panel of an H10 Pro. Later we will go over each of these individual icons here and make sure that you understand how to operate each of the control settings. It has a 12-volt lead-acid battery. Typical life is 3 hours. Charging time is 3 to 4 hours with a wall adapter. It has a heated diode sensor. Typical life is 1 year, maybe 50 to 100 hours is more typical, so it's dependent upon use. It's calibrated as needed, which is one of the beauties of this instrument. You can always calibrate it every time you use it. You start up with it and ensures it is operating as accurate as possible. It has a 4.5-foot probe with a built-in filter. This unit also has a pump inside of it, and it pulls air through that probe to the sensor. Response time is about 1 second. Flow rate is about 90 cc's a minute. We talked about the refrigerants it detects. Here's the sensitivity levels we'll go over. It does have an auto mode. We'll adjust our background gases. Has a 2-minute typical warm-up. And there's 2 indications of a leak. One's visual, where you have a red LED in the probe tip, which will flash faster with the leak. And then you have an audible sound. Usually you have a tick rate that is between 1 and 3 ticks per second. As you get closer to a leak, you start finding a leak, it'll tick a lot faster. So the light will flash in the probe and the audible alarm will tick faster. Weighs 5.1 pounds. There's dimensions. You operate it between 32 and 104 degrees. It has a warranty of 3 years, which does not include the sensor. We talked about the refrigerants, all the refrigerants that it senses with this positive ion emission heated diode. And here's the sensitivity levels that it will detect for the different gases. We talked about the warm-up time, 2 minutes, probe length, 4.5 feet, and the temperature 32 to 104. The H10 Pro sensor uses a positive ion emission technology, commonly known as a heated diode. It is very sensitive to halon refrigerants, in particular making this product highly resistant to cross-sensitivity and false alarms, while retaining superior sensitivity for pinpointing the most difficult to find refrigerant leaks. A pump inside the unit draws air through the probe to the sensor. The presence of refrigerant causes the H10 Pro to sound a speaker and illuminate an LED in the probe. Sensitivity to pinpoint small, medium, and large leaks can be controlled by setting a leak size switch. So heated diode sensors in general detect all types of refrigerants. They can respond to many compounds, including water and temperature changes, like blowing on it because of the moisture in your breath and the change in your temperature in your breath. They require calibrations. They're low cost, and they can last 3 seconds to 50 hours to 100 hours, depending on how much gas they see. The H10 Pro, things you need to know. Before you use the unit for the first time, remove the sticky label disc from the cap of the calibration reference bottle. This disc can be reused to help seal up the valve when the leak detector is not in use, or it can be discarded. Do not attempt to unscrew the cap. You may damage the bottle. The calibration reference bottle should last approximately 6 months. With the power switch in the off position, Charge the battery using the wall adapter. Charging time is 3 to 4 hours or until the unit is the full charge LED turns green. The instrument has not been designed to be intrinsically safe, and could be the source of an ignition in areas classified as hazardous locations with an explosive or flammable gases present. For your safety, do not use the H10 Pro in hazardous classified locations. Do not use this device to detect for leaks of refrigerants which are rated as combustible flammable gases. Example, ASHRAE A2 or A3 rated refrigerants. Submerging the probe in liquid will damage the pump, as it will pump up that liquid. Exposing the probe to pure refrigerant will severely reduce the sensor life or destroy the sensor. Life of the sensor is directly proportional to the amount of exposure it has to refrigerants. Exposure to high concentrations of refrigerant may require adjustment of the sensor heat. Average sensor life 50 to 100 hours based on normal use. Consistent and/or constant exposure to high levels of refrigerant will deteriorate the sensor life more quickly. Increasing the sensor heater adjustment will also impact sensor life. Note, the sensor does not operate when the low battery LED is on, even if the pump is still running. So when that low battery LED light comes on and it's red, even though you hear the pump running, that sensor is not working. So at that point, you have to go to a wall charger, plug it in and charge it, or if you have the unit on, you can plug it in and continue to do your leak detection. There are variations in sound of pumps on H10 Pros, which do not affect the operation of the units. The important factor in determining proper pump operation is to check the ball in the probe is floating while the unit is running. How to determine proper pump operation? Check for sufficient airflow by pointing the probe tip towards the floor, covering it with your finger, then releasing your finger. If the proper flow exists, the red ball should noticeably rise up into the probe when you uncover the probe tip. Note that the actual height and the final resting position of the red ball are not important. If the airflow ball does not rise, tap the probe lightly to make sure the ball is not sticking. Replace a filter in the probe tip. If the flow is still insufficient, then the unit should be sent in for repair. H10 Pro leak detector settings and controls. This is a faceplate and control panel of the H10 Pro. On the left here, we have the battery charge status LED. Okay, it takes 3 to 4 hours to charge this unit. When it's fully charged, this LED turns green. When it's charging, it'll be red. This is where you plug in the charger from a wall adapter. This is your power on and off switch. So when you're charging it, if you have it in the off position, it'll charge. If you turn it on and you have the charger in, you can do leak detection. This is your low battery LED. When it turns red, as I said before, you can no longer use this unit. You have to either charge it or plug it in. Over here, we have a manual and an automatic switch. I'll go over those two things in the next couple slides. In the manual switch, you have a manual balance control here that you would use with it. And you will have a tick rate, 1 to 3 ticks per second, tick, tick, tick. And if it's a lot higher than that, then you want to start turning this down till you get that 2 to 3 tick rate per second. And as you get closer to the leak with your probe, it'll start ticking faster. Then once again, you adjust this down. A lot of leak detectors have a thumb wheel on them, whether combustible gas or refrigerant leak detectors, and you do that same thing, and that's how you go find a leak. If you put this in the auto mode, when you put the probe into gas and you start getting a faster tick and the light in the probe flashes faster, if you leave it there for several seconds, then it will automatically adjust to that. And it'll go back to several ticks per second, and then you can go further and look for the leak. The manual mode is more sensitive, and you will find more leaks in the manual mode. Over here, you have your leak size switch. So you have a large leak, medium leak, and a small leak. The manual suggests you go in with a large leak, and you look for large leaks and go through the system. If you don't find one, then depending on the refrigerant you have, you will go either medium or small. If you have a CFC or a HCFC refrigerant, you would put it on medium. If you have an HFC refrigerant, you put it on small. That's that way to protect the sensor. Some contractors don't do it the way we tell them, and they go in and they either go medium or small depending on which refrigerant, because they say they don't want to do it twice, and they'll look for a leak and find a leak. If they go in there and it's just constantly ticking and they can't get it down, and it's flashing, then they'll go in and they know they have a large leak in that area, and they'll put it on over in a large. Over here, we have a calibration bottle. This is a bottle I talked about where you have a foil paper cover on it. You peel off, this sets in here. You take the probe, you swish it over that leak detector, and you will get these lights flashing to tell you if the sensor is at the proper heat. If you take the probe and run it across this leak detector, calibration gas, and it goes from low, a red on low, to a green okay, and then back to low, it's working perfectly. If you swish it across there and it goes from low up to high LED and stays on high, that sensor is too hot, and you have to get a screwdriver, put it into this heater adjustment, turn it counterclockwise to lower that heat going to that sensor. If you swish it across there and it just stays on low, that red LED, and it stays on low, you don't have enough heat. So you have to go in here and crank it clockwise to put a little more heat on that sensor. Because ultimately you want to be able to switch this across this calibration gas, and it'll go from low to okay, back to low. Your adjustment's good. So once again, they're going to go over the auto mode versus manual mode. The auto mode enables the H10 Pro to block out background levels of refrigerant. This greatly reduces and eliminates false alarms while retaining sensitivity to quickly locate small and medium-sized leaks. Pinpointing leaks in this mode require continuous probe movement. If the probe is held stationary over a leak, the unit will automatically zero out that leak, go into idle 1 tick per second condition. Briefly moving the probe away from the leak, 1 to 2 seconds, permits the unit to re-establish sensitivity. Returning to that leak site, the unit then will alarm again. Continuing this procedure will reliably and repeatably pinpoint the leak with each pass over the leak site. If a large leak is present, the auto zero circuit may reduce sensitivity to an unacceptable level to find small and medium-sized leaks. If this condition exists, use a manual mode to pinpoint a large leak. The manual mode is also effective means to determine if a large leak of any refrigerant exists prior to searching for leaks. The H10 Pro Auto Mode typical operation. Here you have the leak size switch. So you have a large, a medium, and a small. The small switch position is the highest sensitivity. The unit will indicate 0.1 ounce or greater leak rates and is used for fluorine-based gases like R134A. This position also assures highest repeatability for locating 0.5 ounce or greater 134A leaks per SAE standard J1627, moving probe test conditions. It must be used to verify performance and calibration when you use the calibration reference bottle. So when you use that reference bottle, you want to put it in the small switch position. Medium switch. Medium switch position is used for chlorine and chlorine-based gases like R12, R22, R1234, etc. and will indicate a 0.1 ounce per year or greater leak rate. This position supports finding a 0.5 ounce or greater leak during the moving probe as defined in test SAE J1627. It is also useful for locating larger 134A leaks of 1 ounce or greater. The large switch position is used to zero in on large leaks, 0.1 plus ounce of any refrigerant. If a large leak is suspected, switch the unit to the manual mode, adjust the manual balance control for 2 to 3 ticks per second, and slowly approach the test equipment area. Adjust the manual balance control counterclockwise as necessary to maintain 2 to 3 ticks per second. So this manual balance control, you can see from this presentation, you're going to adjust it sometimes counterclockwise, sometimes counterclockwise to get that 2 to 3 tick per second. In the manual mode, the auto zero circuit is disabled. The unit will not zero the leak if the probe is held over the leak site. This mode may require frequent readjustment of the manual balance control to maintain the required 1 tick per second that indicates proper adjustment, and calibration for these 3 sensitive switch positions. Manual mode provides greater sensitivity than the auto mode. If a large leak is present, the auto zero circuit may reduce sensitivity to an unacceptable level to find small and medium-sized leaks. If this condition exists, use the manual mode to pinpoint a large leak. The manual mode is also an effective means to determine if a large leak of any refrigerant exists prior to searching for leaks. Let's talk about sensor adjustment. Here's where you adjust the heat for the temperature for the sensor. The sensor's in behind this cover right here. Here's the hinges, so you lift it up from the right-hand side. If you want to increase the temperature, you go clockwise. If you want to decrease it, you go counterclockwise. H10 heater adjustment. H10 adjustment and calibration for optimum performance. The calibration reference bottle sensor heater circuit controls the sensitivity of the unit. A heat setting that is too high causes instability due to excessive sensitivity and shortened sensor life. The low, OK, high LEDs in conjunction with the heater adjustment and calibration reference bottle is a unique system for setting the correct sensor heat sensitivity for optimum performance for long sensor life. The unit is preset for optimum initial operation. So what we're saying here is this unit is really unique. A lot of refrigerant leak detectors, as you use a sensor more and more, you don't get to adjust that sensor heat. And so it gets less and less sensitive during its life. With this unit, well, the beauty of the H10 Pro is you can constantly set the heat for that, so it's always operating in the exact calibration that it should be from day one. Slide the mode switch to auto, turn the unit on, and allow it to stabilize for approximately 2 minutes. When stabilized at 2 to 3 clicks per second, briefly touch the calibration reference bottle with the probe, after removing the sticky label from the top of the bottle. If adjusted properly, the red low LED will go out, the green will go on, and briefly glow. This indicates the sensor's heat sensitivity is adjusted for optimum performance. If the red low LED remains on when you briefly touch the bottle, the sensor heat is too low and the heater adjustment must be turned slightly clockwise. Allow unit to stabilize for about 1 minute and then retest. Repeat this procedure until the green OK LED briefly glows. If the red high LED glows, the heat is too high and the heater adjustment should be turned slightly counterclockwise. Allow the unit to stabilize and then repeat the test. Continue this procedure until the proper green OK LED indication has been achieved. So here you can see where we're touching or running the probe across the bottle to start the test. And here's where you adjust the heater. Here's some notes and tips. After initial check for correct adjustment, disregard the low, okay, high LEDs. Their indication is meaningless during the leak test activity. So, you know, as I said before, when you're using this unit, how are you going to find that you have a leak? The indicators are in the lights in the probe. That's the only light you're going to be looking at to see if you have a leak. It's at the tip of the probe. It's a red LED, and you also hear a faster ticking rate. So that red LED will start flashing faster, and the tick rate will go faster. Anything on the display panel, disregard. Those have nothing to do with finding the leak. Check for proper heat adjustment the first time the unit is turned on, and repeat on a daily basis. This assures a product is calibrated for correct sensitivity for all leak sizes, size switch positions for your daily test activity. Frequently of sensor heat adjustment is a function of how much exposure the sensor has to refrigerant. Adjustment may be required every couple of weeks for heavy-duty service and once every few months for light-duty service. The sensor LED status indicators will accurately tell you when the adjustment is necessary during a daily check. Over the usable sensor life, when the heater adjustment is fully clockwise and the green LED OK will not come on, it's time to replace the sensor. So when you've been adjusting that and the heater adjustment up there in the upper right-hand side, and you can no longer go any further clockwise, and that green OK LED is not on, you have to replace the sensor. Before plugging in a new one, turn the heater adjustment fully counterclockwise, then plug in the new sensor and test and adjust as described above to calibrate the instrument. Okay, so when you put in a new one, and by the way, make sure that sensor is not hot when you go to pull it out. So let it cool off, unplug it, or you can unplug it, but pull it off when it's cool. Turn the heater adjustment all the way to the left, counterclockwise. Put the new sensor in, and then make sure that and then adjust it the way we've talked about above. Where the cover, there's a sensor, glows cherry red when it's hot, and there's replacing the sensor. Replacing the filter and airflow indicator. To protect the air pump from damage to foreign particles and moisture, replace the filter as it becomes dirty. With moderate use, 15 to 30 minutes a day, it is recommended the filter be replaced once a month. In dirty environments or heavy use, replace the filter more frequently. Always replace a filter when it is visibly dirty or wet. How do you replace it? Remove the black tip of the probe. Pick out the filter with a pin or tweezers. There will be a fine screen that stays in there. Insert a new filter in a probe tip and make sure it rests against that fine screen. Put the rubber tip back. The airflow ball, if that's bad, you want to replace it with a new one. Remove the clear plastic section in the probe by gently pulling and twisting. Turn the probe tip upside down and tap it to remove the airflow ball indicator. Insert a new ball indicator into the tip and then reattach the probe into the probe assembly. Here's some descriptions and part numbers of replacement parts. You can get tune-up kits, which includes a sensor, filters, airflow balls, rubber probe tips, and calibration bottle. You can buy them all individual, but it's nice to buy them in a kit. This kit includes a sensor, and a calibration bottle. This one, just the calibration bottle and the filters and that. It's your choice. I appreciate everybody listening. This is in no way in lieu of reading the manual. I suggest you still read the manual. There's still other tips in there. It's an easy to read, fast manual. And then you can also go on our website, www.mybackrack.com. That's MYBACHARACH.com, where you can download data sheets or specifications or all the gases this detects. If you lose a manual, you can download a manual from there. Thank you much for your attention.